Hello everybody, very important lesson. I can complete an addition subtraction property mini proof by following its procedure. This is not a simple lesson by any means, but it is very important. It's very commonly asked. If you're going to master proofs, you definitely need to know how to do addition subtraction property. We use addition subtraction property when we have part of what we want. So ultimately we're proving that this green triangle is congruent to this red triangle. So, statements, reasons, AB is congruent to CD, given. So, is AB and CD sides of the triangles I'm trying to prove? And the answer is kinda. It's part of it. AB is part of AC. AC, the green, is the side of the green triangle. AB, the purple, is part of it. When we have part of what we want, that's when we use addition or subtraction property. Now I have AB, I have the purple, I want the green. I have too little, so I need more. So what do we need to add to AB to get AC? BC. All right, that green piece that's left, that's the piece that I need. On the other side, if I'm looking at the red, I have the purple. I need the whole red. What do I need? I need BC. So the second step is what you're adding or subtracting to get what you want. In this case, I'm adding BC to AB, and I'm adding BC to CD. What's the reason for BC being congruent to BC? Well, that's reflexive property. Whenever something's congruent to itself. Now, if I add those together, if I add AB and BC together, I get AC, which is what I want. And if I add BC and CB together, that gives me BD, which is what I want. So now I can state that AC is congruent to BD. Addition property. However, I do need to see the addition. So why is it addition? Well, to get AC, all right, or I added AB plus BC, and to get BD, I added CD plus BC. So the third step is ultimately what I want, the side or angle of the triangle I'm trying to prove, but write or and show me the addition, since technically for addition property, I need to see the addition. Let's take a look at the next one. Statements, reasons. AC is congruent to BD, given. Is AC, and let's get some colors here, so I got AC, I got BD, I've got green triangle, I've got red triangle. Are those sides of the triangles I'm trying to prove? Kinda. It's too much. So since it's too much, it's giving me this purple here. I want the green. So I need to take away. What do I need to take away? Well, the leftover purple piece, BC. From the other side, it's giving me BD. I want CD, that's the side of the triangle. So what do I have to take away? BC. So the second step, just like what we did in the previous example, is what I'm adding or subtracting to get what I want. The reason that BC is congruent to BC is reflexive property. And now that I have reflexive property, if I subtract those, I get what I want, which is AB and CD. How did I get those? Subtraction property. And I need to see the subtraction. And this is what I subtracted. AB was AC minus BC, and CD was BD minus BC. And that's subtraction property. All right, let's move on to angles now. Number 3, ultimately I want triangle EIC, this green triangle, to be congruent to HIN, this red triangle. So, statements, reasons, angle EIN is congruent to angle HIC, given. EIN, HIC. Are those angles of the triangles I'm trying to prove? Kinda. It's part of it. EIN, this right here is the angle of the green triangle. I have part of it. I have this part. So what do I need? I need this purple part. So for the green triangle, I need angle NIC. Let's look at the other side. For the red triangle, I have this. The angle of the red triangle is this whole thing. Well, since I have this already, I need this piece, NIC. So again, angle NIC is congruent to angle NIC. The reason for that is reflexive property. And now, if I add those together, I get what I want, which is the yellows. I get angle EIC is congruent to angle HIN. And that's addition property, because I added those middle pieces. And I need to see the addition. And basically, to see the addition, I'm literally just adding this and this. So I write or angle E equals floppy, angle EIN plus angle NIC equals angle HIC plus angle NIC. So it works for both sides and angles. Again, it gave me this little black angle, but that's not the angle of the triangle. This is, so I needed this piece right here, angle NIC. Same thing on the other side. That's it. Let's do the subtraction version of this. Ultimately, it says that I want EIN, the blue, to be congruent to HIC, the red. Statements, reasons, angle EIC is congruent to angle HIN, given. This is EIC. Let's just focus on one of them. Is that an angle of the blue triangle? Kinda. It's too much. The angle of the blue triangle would be this piece right here. I have too much, so we need to subtract something away. What do I have to subtract away? This yellow piece, angle NIC. Angle NIC is congruent to, now let's look at the red, HIN. Well, this is HIN. That's way too much. This is the angle I want. I need to take away this yellow piece, which again is angle NIC. The reason that those are congruent, they're the same thing. That's reflexive property. And now that I have those, if I subtract them, I end up with what I want, which is angle EIN being congruent to angle HIC. That's subtraction. I subtracted those NICs. And I need to see the subtraction. So I write or, and I'm subtracting this, and I'm subtracting this. Angle EIC minus angle NIC equals angle HIN minus angle NIC. That's addition subtraction. I said it's usually reflexive as the second step. It doesn't have to be. So let's take a look at let's just jump to number 6 here. Ultimately, I want to prove triangle MOE. The blue is congruent to NKM. The red statements, reasons, MN is congruent to NE, given, NN is congruent to NE. That's not right. I'll just pause it for a moment. Okay, it is right. So, MN is congruent to NE. Now, it's a little misleading because MN is the side of the red triangle, but NE is not the side of the blue triangle. So that does not count as one of the sides of the triangles I'm trying to prove. But if I look at this blue side, MN is part of that blue side, and NE is part of this red side. It's too much, so I'm going to have to use subtraction. So let's just color the whole thing. Let's just do it this way. This is what I have. I want the blue. So what do I need to take away? I need to take away this yellow piece, ON. So I need ON for MN, and for NE, I have this. I want this, so I have to take away this piece, KE. Now, it's not reflexive. This is not the same segment, so I need to know that they're congruent. Do I know that they're congruent? Yes, because it's given to me. So it's not going to always be reflexive. It could be given, or when things get more complex, it can come from a lot of different areas. Now, if I subtract those, I get what I want, which is MO and NK. Those are the sides of the triangles I'm trying to prove. So MO is congruent to NK. Subtraction property. But I need to see the subtraction, so I write or, and those are the things I'm subtracting. MN minus ON equals NE minus KE. That's addition subtraction property. When you have part of what you want, that's when you use addition or subtraction property. If I have too much, all right, I wanted the blue, I had the black, I had to subtract the yellow. If I have too little, if I had the purple, but that's not the side of the triangle the green is, I would need to add. What you're adding or subtracting is always the second step, and the third step is what you want, and make sure you state the addition or subtraction. It's always a three-step process. Definitely needs to be practiced. This is very important. If you have to do a proof on the regions, almost definitely you're going to have to do addition subtraction property. You know it or you don't. Once you know it, you use it. If you don't know it, then that's a problem. That's all I got for you. Practice. See ya.